Hello and welcome to this session of CCNP ENCOR series. In this session, I will discuss SD access fabric roles and components. The operation of an SD access fabric depends on multiple device roles, each with a specific responsibility. Based on that, there are five basic device roles in the fabric overlay, such as fabric control plane node, fabric border node, fabric edge node, fabric intermediate node, and fabric edge node. And another one is fabric WLC, which is actually not part of fabric, but it is an important component which is connected to the fabric. So let's start with fabric edge node. A fabric edge node is first hop for the users or endpoints connecting to the Cisco SD access fabric. These are the endpoints, right? These are the endpoints. It provides actually onboarding and mobility services for wired and wireless devices. It's a Lisp tunnel router or XTR and node that is responsible for authenticating and authorizing endpoints, registering the endpoint's identity such as IPv4 or IPv6 with control plane node, and providing a consistent gateway experience using any cast layer 3 gateway. And this node can be either a switch or a router operating in the fabric overlay. Then we have fabric control plane node, which acts actually as a brain of the fabric. Actually, it's a Lisp map server or resolver with enhanced function for SD access. It maintains a database mapping EIDs, that is endpoint IDs, to the RLOCs, that is location. And it handles endpoint registrations and resolve lookup requests from the edge or border nodes to locate destination devices. It supports security group tags mapping for policy enforcement, and it can be a Cisco router or a switch with sufficient scale to handle the fabric's demand. The next node we have is fabric border node. The fabric border node in a Cisco SD access network is responsible for routing traffic in and out of the fabric, like traffic towards internet, data center, or another fabric. These node actually functions as Lisp PXTRs, proxy tunnel routers, meaning they can handle traffic leaving and entering the fabric efficiently. There are actually three types of fabric border nodes. One is internal border, which connects the fabric to the known internal areas like data center, firewall, or WLC. And then there is a default border node, which connects the fabric to external networks such as internet or public cloud. Actually, these default border uses default route to reach unknown destination. And then you can either have internal plus default border, like which functions as both as internal and a default router and connect to both internal system and external networks, handling all types of traffic. So that's about fabric border node. Then there is another one called intermediate node. The intermediate nodes are the network devices like layer 3 or a layer 3 switch or a router that provides underlay services for the fabric. They physically exist in the fabric and are part of the underlay, but they are not part of the fabric overlay. You got my point? Like when you have a big network, you have a distribution layer and all, right? So these devices will be in this type of network. Like the need for intermediate node depends on the physical layout of your network. As I said, like distribution layer aggregation. If your network has a distribution layer to aggregate multiple access layer switches, these distribution devices may become intermediate nodes. So intermediate nodes route layer 3 packets. between other fabric edge nodes, other fabric nodes such as edge nodes, control plane nodes, and border nodes. Any platform that supports IP routing can be used as an intermediate node, even non-Cisco devices. And then we have fabric wireless controller. A fabric wireless enabled wireless controller connects access points and wireless endpoints to the SD access fabric. It is external to the fabric, as I said in the earlier slide, to the fabric, but connects it to an internal border node. And the functions of fabric WLCs include onboarding and mobility, like it handles the onboarding of wireless clients and ensures seamless mobility as they move across the network. PXTR registration, like it performs proxy tunnel router registration to the fabric control plane on behalf of the fabric edges. And then EID mapping. The control plane node maps the host endpoint identifier EID to the current fabric access point and fabric edge node location. And then it also offers policy enforcement, like the fabric WLC ensures the SGTs and VRF based policies are applied to the wireless user just like wired users. If you compare the traditional WLC versus the fabric WLC, in traditional WLC, the WLC is centralized and all control and data plane traffic is tunneled to the WLC through CAP-WAP tunnels. If you see here, that is the CAP-WAP tunnel. Whereas in fabric WLC in SD access, the wireless control plane remains centralized, but the data plane is distributed using VXLAN. If you see here, that is the VXLAN. That's it for this session. I hope this was informative for you. In my next session, I'll discuss about QoS.